Hi everybody, this is the first video of a series of videos today on lesson 7.3, and we're going to be talking about interest formulas and bank account problems, and this is part of our introduction to exponential equations. In the problems that we're working today, I call this round one because in this round I'm going to give you the value that's up in the exponent, and your job is to find the final value, okay? So you're going to be given everything on the right hand side. These are going to be pretty straightforward problems. It's just kind of plug and chug stuff. Do you know how to do order of operations and to simplify the right hand side correctly? Later on we'll come back and we'll do round two, and in that case I'll have you solve for time in each of these, which means finding a way to get that exponent, you know, like solving for x in the exponent, like we've been talking about so far in the class. Before we get going with this though, we need to have a crucial skill in mind, and that's converting between percentages and decimals. See, I'm going to be working with bank account problems that involve like interest rates, perhaps like 5% interest or 3.75% interest. And the problem is this: if you ever enter 90 or 15 or 3.75% in for an interest rate later on in a formula, and you don't change it to a decimal first, you're going to end up with some massive values. You're going to be getting serious rich off of these problems, okay? And one of the big ideas you're going to find out is if you ever invest like $5,000 in a bank account and you come away with $2 quadrillion, you probably screwed something up in the formula, because you're not going to get rich using a savings account or any of these problems, okay? So that comes down to, the main mistake is converting between decimal and percentage format. 90% is the same thing as maybe like perhaps a 90 out of 100 on a test, right? You know what I mean? Okay, so if I take 90 out of 100 on a test, that gives me 0.9 as the decimal format of that answer. So 90% is 0.90. In other words, what I did is I took that number and I divided it by 100, or I could say I moved the decimal point over 2 spots. So the same thing happens here. If I move the decimal point over 2 spots, it ends up being 0.15 for 15%, okay? Or I could say 15 divided by 100 on my calculator, and that'll give me 0.15. And on this one, 3.75%, I need to move it over 2 spots. And then that means I don't have enough digits over here, so I'm going to have to throw a 0 out in front just to make things work. And it's 0.0375. That's the decimal format. Easy way to do that one: take 3.75 and just divide it by 100 on your calculator. And when I do that, 3.75 divided by 100, I get 0.0375, right? You have to do this for every single one of the problems we're getting ready to do, dealing with bank accounts and stuff like that, okay? So just keep that in mind. If you're not comfortable with doing it, just moving it 2 spots over, divided by 100. Now, before I quit this video, let's go through real quick, and all I want to do, we're not going to do any problems. I just want to introduce the formulas here, and these are actually straight off your formula sheet that you get for the end of course exam this year. So this is from the state of Missouri. They're going to give you these 3 formulas. Our job is to understand what each of these letters stands for, okay? So let's start with this one here, okay? When it says I is equal to PRT, that means that the interest gained is what we're working with, okay? That's the interest gained. If I put $5,000 into a bank account, it's not how much I have at the end, it's how much more I have, right? It's the interest gained. And so that's what the I stands for. And what we do in order to find that, they use the letter P to represent the principal. And when we say the principal, that means that's the starting amount. How much did you put in, okay? R stands for the interest rate. And each bank is going to tell you, hey, we're going to give you 1% interest or something like this whenever you put money into our account. That is typically measured in, well, first of all, let's just do this first. That's got to be in a decimal format. If you put 90 in instead of 0.9, you're going to be making a ton of money, okay? Because it's a big deal to multiply by 90 here instead of to multiply by 0.9 here in the formula. And then T stands for time, and typically this is in years, okay? Almost always this is in years because the interest rate is a yearly thing, so the time is also going to be measured in years. All right, next formula is this one. A is equal to P times 1 plus R over N to the NT. Okay, this looks terrible, but I want you to understand that this is really not that complicated of a formula if you just know how to simplify stuff, okay? Much of the stuff that we have is the same. The A is the amount after any given time. Okay, so in other words, that's your final amount in this formula. P is going to stand for how much you have to begin with. Once again, that stands for the principal. And for why they capitalize it in this formula but not that one, I really don't know. Okay, it's the same thing. It's the same P. P stands for the principal, so that's the starting amount. Okay, If for bank accounts, it's how much you put in. A is going to be how much you get out. Okay, so this is not interest gained. It's not how much more you have. It's the total amount. That's your starting plus some, right? The starting amount plus whatever you gained. That's the number one. Okay, nothing confusing about that. R is, once again, the interest rate, and that's in decimal format. If you have a 90 here instead of a 0.9, or if you do 3.75 instead of 0.0375 right there, that's going to be a big deal. T, let's skip the in for a second. T is time. That's in years, okay? Because the interest rate is a yearly thing, so the T is also going to be how many years have gone by. So sometimes they're going to say like, hey, 6 months have gone by. We'd have to enter a 0.5 because it's a half a year. Or they might say 2.5 years go by. Well, that's a 2.5, right? Last thing is in, okay? And this is one that's going to cause us more trouble than anything else. And the in happens to stand for how many times do we add interest per year? How many times do we add interest per year? The N probably stands for the number, N for number of times per year, right? And so what we're going to do here is we're going to talk about some problems later on that deal with simple interest, and sometimes interest is compounded quarterly or something like that. And so really you're going to see words show up, and you'll find out what that N is as we go through, okay? Now, N could be, well, here, let's just walk through that real quick. If you have what's called simple interest, that means that N is equal to 1. That means it compounds interest. It'll add interest to your account one time every single year. If we did monthly, if it's compound interest, and it's compounded monthly, that means we're going to put N equals 12, okay, 12 times per year. Perhaps it compounds quarterly, and that would be 4 times per year. Maybe it's semi-annually, and that would be 2 times per year, because semi means annual, right? Semi means 2, excuse me, or half. Okay, so you will see these phrases show up, and that's all that's doing is that tells you how many times per year is the interest compounded, and what do you need to put in for N to the formula, and then it's just plug and chug from there on out. Okay. Now, there is the specific case where interest might be grown continuously, okay? And the problem is this, is if I say continuous interest, if it's continuously compounded, okay, that means it's growing all the time. Every single instant of every single day, interest gets added to your account, which you'd think would be a great thing until you look at this. You would say, okay, well, P times 1 plus R over times something times T. What do I put in for the N if it's continuous? What if it's doing it every single instant of every single day? That's not daily. Daily, I'd put a number 365 in for T. So what do I put in for every single instant of every single second? Not even like down to the millisecond. It's being added. I'd have to put in the number infinity, like, right? I mean, it'd have to happen infinity times per year. But if I take any number and divide it by infinity, then basically that goes away. But this gets huge. I mean, that's a huge exponent. I raise something to the infinity power, and it's, you know what, that doesn't make sense. We got to have a different formula. And so what happens is we have one new formula, and that's if interest is compounded continually is the only time we use this formula. And that's where this formula comes in. I told you the number E is going to show up in bank account problems. Remember, E is just something around 2.718. Okay, it's like pi. It's just a number that shows up so often. It's a number that shows up so often that it has its own symbol, and it's really because of compound interest that continuously compounds, or continuous growth. A and P, you probably know what they stand for. R stands for rate, okay, and T stands for time in years. R has to be in decimal format. So the only thing you're left to find out is where is the E button on your calculator. And so you'll notice there's a couple of opportunities to do it, okay? If you want to raise E to a power, you have a button right here, and I can type in second, and then hit E to the power, and it'll put the parenthesis in there, and I would have to put an interest rate, like maybe it's 5%, I would put this. Maybe it was for 17 years, I would put that, right? RT, see that? E to the RT, okay? Or, I also have a button over here above the divided symbol, and it's in yellow again, so I'm gonna have to hit second to get to it, but there's the 2.718. So you have a couple of options. If you don't want the exponent, use this one. If you do want the exponent, use this one. Or you can just mix and match. I could type in E, and then I could do the carrot top myself. It doesn't really matter, but know how to get that button in the calculator. And in the problems we're going to do, all it is plug in the stuff on the right hand side in the right spot, simplify that formula, be able to work out and find out what like a final amount is. Hopefully that makes sense. And next video will involve working some problems. That turned out to be pretty long, didn't it? Sorry about that.